Good morning. I am Minakshi Sarkar, Assistant Professor of CSC Data Science. Today I am going to explain the basics of Moore machine and Mealy machine. So till now we have seen the finite automata without output. Today we will see finite automata with output. And these two machines are also deterministic that I will explain in the next time. So now Moore machine and Mealy machine both are 7-tuple machine and both are deterministic. Q, sigma, delta, Q naught, capital delta and lambda. These 7 tuples are present here. Q is same as the DF and NF, finite set of states. Uh, this sigma is the input alphabet, delta is the transition function, Q cross sigma to sigma. This is same as the DFA also. Q naught is the initial state and capital delta is the output alphabet, the symbols which are supposed to be printed as the output. And this output function will generate what will be printed as the output based on the state and the input alphabet. So now first we will see what is Moore machine. This is the diagram of Moore machine. So there are basically two states, Q0 and Q1. So for Moore machine, alphabet, the output function lambda is Q to output alphabet. That means for each state there will be some output. Okay, so see here Q0, the output associated is 1. The state Q1 output associated is 0. So for Moore machine, the state itself generates the output. So that as the name here MOORE, one output is associated with each and every state. Okay, so now we will see how it is happening here. If we consider a string AB, then from Q0 by input A, I can go to state Q1 and the output associated is 1. From Q0 by input B, I can go state Q1 and the output associated is 1. Q1 output associated is 1. From Q0 by input B, I can go to state Q1 and the output associated is 0. So I am getting the output 110 of length 3. But I have given here the string of length 2. So for Moore machine, if we give string of length n, but output produced is n plus 1. So this is the Moore machine. Again I am telling you one output is associated for each state. Now this is Mealy machine. Mealy machine, here the output function is different from the Moore machine. From a given state, by giving some input, I can go or it will generate some output. So suppose two states are here, Q0, by giving input A, it is going to state Q0 and the output associated is 1. Here the output is associated with the transition okay. So from Q0 by giving input B, I can go to state Q1 but output associated is 0 here. Same from Q1 by giving input A, I can go to state Q0 but the output associated is 1. Again from Q1 by giving input B, I can go to state Q1 but the output associated is 0. So if I see a string AB, then from Q0 by giving input A, it can go to state Q0 but output is 1. Same for from Q0 by giving input B, I can go state Q1, output is associated, that is 0. So for the length of string 2, I am going to get two output, two length of output string. Okay, so this is the basic difference between Moore machine and Mealy machine. Next we will see some examples of Moore and Mealy. So this is example 1. Construct a Moore machine that takes set of all strings over AB as input and prints 1 as output for every occurrences of AB as substring. So now from this question, first write down the alphabet set that is given AB. And this is the output alphabet. Why I have taken here 01? Because the question says it will print 1 as output for every occurrences of AB. So actually we have to count the number of ABs present here. So that's why we are taking the output alphabet 0 and 1. If we get only one AB, it will print 1 one time. If we take a string AB, then how many times 1 will be printed? 2 times. Okay. Now, for drawing this determinate finite automata, first of all, we will try to like this way, starting with AB. If we take starting with AB, then there are basically 3 steps. ABC. So starting with AB, then only one AB is there, and I cannot keep a count of how many. If I take AB, how many ABs are there? Starting with AB, and if I also take another one, suppose ending with AB, starting with any number of AB. Sorry, and not ending with AB, containing AB. In the first time, there can be any number of B, then in the middle AB, and after that, any number of AB can be generated. So I cannot keep a count here also for this case, containing AB. But if we see ending with AB, that is the diagram. Three states are here, A, B and C. So now it can start any number of B, then A, then B. The final state is C. It can be the accepted state where the string is ending with AB. Okay. So then after ending with one time AB, if it gets again A, then it can go back to this state, and if it gets B, it can go back to the initial state again. Oh, see, so this is the exact diagram for ending with AB. Okay, and I told you that if I get AB, then it will print 1. Okay, so this that is why I am considering this state as the accepting states, and that is why it will print 1. Okay, for other states it will print 0 because no ABs are generated here. Okay, so if we see the example AB, this is the string from A. By giving input A, I can go to state B, and this is motivation. So output state itself is generating the output. So A is generating 0. From B, by giving input B, it can go to state C. But B is generating the output 0. C is generating output 1. Okay. So now from C, by giving input A, I can go to state B. B is generating output 0. From B, by input B, I can go to state C. And the state C is generating output 1. So how many ABs are here? 2 ABs. That is why two times these ones are printed here. So this is the example of Moody machine. Next we will see another example. This is construct a Mealy machine that takes binary numbers as input and produces 2's complement of that numbers as output. And assume that the string is read from LSB to MSB and 8 carry is discarded here. Okay. So from the question, first of all, write down the alphabet set, that is 0, 1, and this is the output alphabet. I have taken here binary number also because this is all about the binary number. So before directly going to this problem, first of all we have to know how we can calculate one's complement and two's complement. And first of all we will solve this problem for one's complement, then we will solve the two's complement. Okay. So if we take this string 1010, first find out the ones complement. 1 will be converted to 0, 0 will be converted to 1. This is one's complement number. Okay, first draw the diagram for it. So there is only one step, that is initial and final both. So this is Mealy machine. So in case of Mealy machine, the output is associated with the transition, not the step. So that is why I have written here the output. Output is 1 here, output is 0 here. Okay. So this is the input string 1011. So if I give one input from this state, I am going to get the output is 0, and if I give input 0, then I am going to get the output is 1. Okay, so now I will see for this one 1011 is my input string. From Q naught, by giving input 1, I can go to state Q naught. Yes, I can go to state Q naught. but for 1 the output is 0. From Q naught, by giving input 0, I can go to state Q naught, same state, but for 0 the output associated is 1. And from Q naught, by giving input 1, it can go to same state, but output associated is 0. From Q naught, same for 1, output associated is 0. So I am getting the output 0 1 0 0, and that is same. That is the ones complement of the exact given input stream. Okay, so this is the Mealy machine for finding generating the ones complement of the input stream. Next we will see how to generate the two's complement of that number. So first of all, we know that how to calculate two's complement number. First of all, we have to calculate one's complement. After that, we have to add one with it. Then finally, we will get the two's complement number. So this is the two's complement number. Another one trick we can follow here. So as this is my actual string, so we have to start from the left side. How many times? As many. If you get zeros here, you just leave it as it is, and after that the first one, when you get, leave it as it is. After getting the first one, whatever you will get, you just complement of it, just write the complement of it. So 0 0 I am leaving as it is, 1 I am leaving as it is. After that 1 will be complement of it, that is 0. So this is the two's complement of this number. Okay, so now if we consider this example 1100, first find out the two's complement. Consider from here 0000. 1 leave as it is, 1 will be complemented of 0. And remember, you have to read it from LSB to MSB. Okay, so this is my diagram. This is the initial state. For all zeros, leave it as it is, and after that, if you get first one, leave it as it is. After getting the first one, whatever I will get in this state, 0, if I get 0, it will be complement of it. If I get 1, then I have to write the output as just complement of it. Okay, so this is the diagram of Mealy machine for this example. So if we see this one 1100 is my actual string, so we have to read it from LSB. So 00110011, like that I have written. So Q naught to 0, Q naught to 0, it is going to the same state, and output associated is 0. Q naught to 0 going to the same state, output associated is 0. Q naught to 1, this is the first one. It is going to state Q1, but output associated is 1 here. After getting the first one, Q1 to 1, I am going to state Q1, output associated is 0 here. Okay, so this is the example of Mealy machine. So thank you. This is all about my today's lecture.